Mm. Bra erfarenhet. Bra erfarenhet.
Det går lite mellan use case 1. Så börjar man med main scenario.
Mm.
Det är nog inte svårt att skriva testcase till det. Det kan vara med 4B. Och så, det ska visas ut felmeddelande om typ mappen är skyddad eller låst. Man kommer åt den eller vad man inte har behörighet. Det är jävligt lätt att testa det.
Jag lyssnade inte riktigt på slutet där för jag höll på med något annat. Men,
jag upptäckte bara att andra delar var inte lika lätt som första delen.
Nej. Hej Niklas.
Tjena.
Nej. Vilket var 4B då?
Det var när du startar servern
Mm.
och inte har behörighet till mappen eller något sånt där.
Just det.
Så ska det komma ett felmeddelande.
Mm. Just det.
Man antingen kommer på ett sätt att
Ändra behörighet. Ja, jag hör bara att det är någon som pratar med mig. Men jag ska... Hör du, blindgubbe.
Här är jag. Hörsan Johan.
Hej.
Har du tid en stund?
Absolut.
Så mycket?
Ja, nej,
Okej.
men jag har inte så mycket tid. Det vill säga jag ska hålla en föreläsning om några minuter här. Men du vill prata om labb?
Ja, jag tänkte det.
Ja. Men jag ska visa dig någonting nu. Det är 10 minuter tills föreläsningen börjar. Mm. Så... Okay, welcome to software testing, and this is lecture 5, I think. And today we're going to talk about test generation from requirements and from code to tests. But I think it's reasonable, since we have much of this course is really about the assignment, and I want you to spend a lot of time with the assignment. So, and this week it's the examination week for assignment 1 part 2, which is basically an oral exam. It's individual oral exam, so you should have signed up on Friday, and you should show up on your examination time. And if you're doing the examination of assignment 1 part 2, let's first check that we have sound. Do we have sound? Mic problem. Okay, thanks. So it looks a bit low. This looks better, right? Okay, it was you. I'm gonna place the microphone a bit closer to my mouth. Is this better? Okay. So, just as me giving lectures online, you need, if you're going to do this the examination online, you need to make sure that you have a headset, that you've set up sound. We're going to use Slack, and I would prefer a webcam also, so that I can see you and you can see me. And then you're probably going to share your screen in Slack. And even if you're doing this here in Kalmar or in Växjö during one of those sessions, I want you in the beginning of the session to have your programming environments with your tests started and your GitHub open. And I also want you to look through your GitHub commits up until the deadline on Friday, and look for a couple of series of red-green refactor commits during this, which you think is showcasing test-driven development, so that we can find these commits pretty easily. So you may open these up in separate tabs in your browser, for instance, so that we can look at a red, a green, and refactor, because we're going to look at some of these. And then it's going to be an oral exam, so we are going to ask you questions, and you're going to answer, and we're going to make notes. And yeah, hopefully you will do fine. And I mean, we're not scary people, so we're just trying to find out what kind of level you're on. So, sound is okay, good. Okay, so does the oral examination on part 1.2 include all the lectures? I would say it pretty much does. Much of the things that we mentioned during the lectures are also sort of part of the study questions for 1.2. It mostly is the lectures that is about unit testing and unit testing assessment. I also got a question on assignment 2. When planning the 40 hours in assignment 2, should one include documentation and such as strategy and test plan? Yeah, I think for 40 hours. But as with most usages of time, one could spend 39 hours on these documents, and that wouldn't be a good way of spending your times, right? Your time. And depends on the student how fast you are as a writer, how used you are with something. So there might be students that need to spend even more time than 40 hours on this assignment, as usual. Just as with a programming assignment, I don't know if you know, but in programming assignments, I have seen variations of 20 times. So one student finish an assignment in 30 minutes, that takes like 10 hours for another student or something like that. So, I mean, it's huge variation. So me giving you 20 to 40 hours to complete this assignment is more or less a thought something that is supposed to make you plan your time and supposed to result in something like that. You can end up with some kind of trouble during this that makes it take much longer. Also, I mean, learning should not totally be included in this time. But of course, it's also included. Okay, and in use case 1, alternate scenario 4b says the web server could not be started due to a restriction and on the shared resource container. Does that mean that it should exist such a restriction on a certain folder, or should one be able to create such restriction in some config? Or maybe as you, okay. So this is sort of a security requirement. You should not be able to share resources using the server for resources that the server don't have access to. So perhaps you need to create, I mean, to test this, you need to create a folder or choose a folder which you don't have access to, or the user that runs the web server don't have access to. So this could mean that you need to create another user or use a folder which perhaps the root user or something like that has access to. So, or that you like change the restrictions. Like in Linux, you can easily use the command chmod to change the restrictions so that one user don't have access to reading a certain folder or writing to a certain folder. So I mean that could also be used for this. I would test this by having another user, creating another user, give that user privileges in this folder, or using that user as the user who is starting the web server, and then have another user that has no access to this folder. So that should be the way to test this. And I mean, in Linux, this is pretty easy. We could like change folder restrictions, make sure that the web server don't have access, then run the web server and see that it produces the correct error messages, and that we cannot access this folder. Did that make sense? Someone is nodding here. Okay. So yeah, so most of the week I'm going to be busy with these examinations. So I will be a bit less active in Slack. Continue to write questions in Slack anyway. And if you know the answer to someone else's question, then please answer. Otherwise, I mean, we're going to monitor Slack, but not perhaps as frequent as you are used to now. So let's talk about test case generation. And just to repeat, this was the different parts that we had for a test case. So in order to test something, we need the thing that we're going to test, the system under test. In this case, it's the max function. So the function system under test is the max function that takes an x and a y as arguments. And in order to have a test case, we also need specific test input. Test data, I'm sometimes calling this. Test data or test input. So for this test case, we have input x equals 3 and y equals 4. You should not say that x is any integer and y is any integer. This should be specific values. And this is the case even if you're not inputting like numbers into a function. Even if you're like moving the mouse and clicking somewhere on the screen, that should also be specific. And the reason for that, we probably talked during the first lecture, was that we don't want these tests to be ambiguous. And we don't want these tests to be flaky. An ambiguous test was a test where we, as a tester, needed to interpret the test, make an interpretation. And if it says that x can be any number, then I need to interpret that and then I select a number, -4 or something like that. And if I select a number and interpret the test, other testers are going to select other numbers and interpret the test differently. That is what it means to be ambiguous. So it's not clear how to test this, so make sure that your tests are clear. If we have ambiguous tests, then we might end up in flaky tests, which means that for some inputs that perhaps were not specified, the test fails, and for other inputs, the test succeeds. So with ambiguous tests, we might end up with flaky tests. And flaky tests were tests that without any changing of the system under test, the test shifts between succeeding and failing. And that is bad because we cannot know if we fixed a bug. If this was a bug, we don't know if it's fixed, because even if the test succeeds, we might fail with some other input. So I want all your tests to have specific input. Okay, just as specific input, we also want a specific output. And in this case, the maximum number between 3 and 4 should be 4. So we specify that also. And then we run the test, and this is not, I mean, the actual output and the observed output is not really a part of the test case itself. It's more a part of the process. So we need to run the system under test with the given inputs, and we need to capture the output. And in this case, we run it, it becomes a free, and then we observe this free, and we decide as oracles, we decide that this is wrong, because it should be a 4. For other functions, not max, we might consider free a correct answer, even if the expected value is 4. If this is some mathematical calculation with numbers that are in the millions, in the range of millions, perhaps we can have a span that says that everything is okay between 0 and 5 or something like that. But that is also a bit ambiguous, right? If we say that. So, but we can have that. Okay, the observed behavior. Okay, we're going to talk about use cases and test cases for manual tests, because this is a part of assignment 2. So first, let's take a look at how use cases can look like. So this is a requirement specification. It describes a system. Usually you have both use cases and some kind of supplementary specification. And the supplementary specification are things that perhaps are not as easy to create use cases for, or are things that it's not about the real function, it's non-functional requirements. It's like how fast things should go, or how usable it should be for people with disabilities, or things like that. So we can see that system provides helpful error messages. That is sort of, I mean, you need some kind of user interaction testing in order to understand if these messages are helpful. System should be secure and things like that. It should follow web standards. And then we have the use cases, and this first use case is like this. It's called authenticate user, and it starts when a user wants to authenticate. The system should ask for username, password, and if the system should save the username and password, the user credentials. And then the user provides username and password, and then if everything goes okay, system authenticates the user and presents that authentication succeeded. And then we have, I mean, this is the main success scenario. So we can easily see that, okay, in order to test this, we need specific input for username and password and this Boolean flag here. And then we give this specific username and password, and then we have the authentication. And then we, from this presents that an authentication succeeded, we need to derive the expected output. Problem here is that this doesn't say, the use cases by design doesn't say anything about any form, doesn't say anything about any buttons, doesn't say anything about perhaps specific error messages and stuff like that. And so if we're going to implement this system, we could do that as a web application with this HTML form. And this web application perhaps talks HTTP protocol, or it should talk that protocol, and send these these requests to a server and stuff like that. But the use case here doesn't specify that that is the case. So the use case itself could be implemented perhaps by a command line login instead. Perhaps we're interacting with the command line, and if the system asks for username, password, and if the system should save the user credentials, perhaps that is just a system out or system print line or console log call. And then user provides username and password. That doesn't need to be one single interaction with this through a web form. It could be that first I'm writing my username, and then on the second I write the password, and then we have some other interaction and error messages and stuff like that. I don't have that application, so. But use cases don't contain enough information themselves to write test cases. So you need an implementation, or at least something that is much similar to an implementation, to know how to write these test cases. When you have an implementation that you fairly understand how it's supposed to be used, and a requirement, then you can check if these are the same. But you need some understanding of both the system and the requirements, which means that you need to read the requirements and think of how could these kind of systems work, and you need to interact and play with the implementation to see how the developer has implemented the requirements. And then we come up with test cases for this. So in this case, we have a username text box or input, and then a password input, and we also have this button for login. But in another implementation, correct implementation, perhaps we don't have this button. Perhaps we have another button that says welcome or log me in, or perhaps we don't have a button at all. You just press enter when you entered your password. And in other implementations, you first write your username, and if that username is correct, then or exists, then the password is coming up as a second dialogue or something like that. I mean, there can be multiple ways of interacting. So you need a good understanding of the system. This means that for assignment 2, you need to spend some time with the software that you were given from me, and like interact with it. How is it supposed to be used? In order to do some, so you need to do some exploratory testing first for most test cases. Okay, so that was the use cases, and let's look at the test cases I provide for you to look at. So in this case, we have a test case. There is some description of the test case, and then we have some input, and then some expected output. In unit testing, if we write a unit test for a class or for a method, then I said that the name of the unit test is usually something that is described as Max should return the leftmost item or something like that if we provide so that when the test case fail, we can read the name of the test case and then we understand what the problem is. Usually with unit testing, you only want one output. But with manual tests, these are a bit more expensive to run. To execute these manual tests might take more, or does take more time, because I need to start up the application, I need to do some input, and then it's more, it makes more sense to look at more things as expected output, because we only want to input this once and then we can look at different things. The problem with having 3 different things as expected output is that if one of these 3 fails but the other 2 succeeds, then the entire test case fails. And we, in this case, if the login form does not show, we only see that the navigate to page test case failed. If we are doing this manually, of course we just write a note together with the failing test case that the problem here was that the login form was not shown. And then, I mean, the problem with having multiple expected outputs is sort of fixed. To make things less ambiguous, I include a screenshot of the expected output. And so if you run the test, or when you explore the system and you come up with these test cases, you can take screenshots and include those in your, this is how it's supposed to look. But if the test fails, then you cannot create these screenshots, right? Unless you sort of fix them. I mean, you can take a screenshot and then you draw the things that should be here, right? So, but then we're sort of imagining things, we're in that region. And I've said before that testing is, I mean, should, it's not a stupid process. It's not just looking at entering input and checking output. It's not only that. You should think as a tester. You should think as a user of the system. You should do things. You should use your head and think about is the goals of the stakeholders fulfilled with this system. Okay. Another test case for the same use case is, this was, for the same use case, is to fail to log in without entering any, any entered fields. The description is pretty short, does not really include the things from the first test case, even if many things are similar here. So instead, I write that as input to this test case is the input of test case 1.1. And to clarify that these things should be empty, I just make sure that the tester knows that these should be empty, and then the user should press login. So if we're going to do this, okay, we navigate to page. We've already done that. Perhaps it should look like this first. So we navigate to page, and then we make sure that these are empty, and then I press login. Now I have executed all the steps of the test case, and then I look at the output. The text not logged in is shown, so I copy that. Search for that. Okay, it's shown. Sure. Username is missing is shown. Yeah, fine. A form for login is shown. Sure, it's still shown. So all 3 outputs is shown, so the test case succeeds. Could be quite nice to have in this test case also have some checkboxes where I can check this succeeded. I mean, probably you will not print this. And probably it would be better to have some kind of support application where you write these test cases, like a Google spreadsheet or a Google form that is showing you these instructions, or showing the tester these instructions, and the tester is able to say that this succeeded, and we can generate reports or so from that. But I mean, for these assignments, it's pretty basic stuff. It's not much data. You're not going to test these over and over again. So introducing such software is overkill. Same thing as for the other one. I have a screenshot here. Then I have a third test case, fail login with only username. Explain why it's important. Make sure login cannot happen without entering both fields. We write, actually this one is test data, right? So specific input. You should not write Kalle there or something, some other name there. Or it should be a user that actually exists. And you let the password be empty, which is also input, right? It's also specific input. And then you press login button. And we have a lot of these test cases. Actually, many of these test cases are for the same use case. So if you take a look at this use case, authenticate user, we have different scenarios of this. And a scenario was a different path through the different steps in the use case. And I've talked about this the last lecture and shown you this. So the main success scenario was 1, 2, 3, 4. And the scenarios so far that we've looked at was 1, 2, 3, and 4A. And sort of step 2 is that it should ask for username, password, and if the system should save the user credentials. So it's 1, 2, 3, 4A, and 2, more or less, are the different steps that we looked at, the different scenarios here. 1, 2 was the first, and 1, 2, 3, 4A, 2 was the second. And I actually have many different test cases for this path, because the way that we can fail, there are so many ways we can fail. And I think if we take a look at this, fail login with existing password but wrong username, fail login with wrong password but existing username, fail login with only password. So I mean, there are, yeah, 5 or 6 different failing test cases that are more or less just taking this 1, 2, 3, 4, A2 path. And the reason for having so many test cases there is that we, in the requirements, said that we needed to have user-friendly error messages showing the user why we fail. And in order to have so many different cases, we needed different error messages, and then we need different test cases. So it's not only looking at the in order to find all the necessary scenarios or all the necessary test cases for a single scenario, I mean, we need to think a bit further than just from the requirements. And sometimes these different paths are only available in the code, because it's interpreted, that these requirements are interpreted by a programmer, which makes an interpretation and comes up with a number of different cases. So we might need to look at the code or try different things and find different scenarios. So here we have the test cases that are related to use case 1 in my example. So We had the first one, navigate to page, failed login without entering any fields, which is more or less just the 1 and 2, and not the other parts, because we don't interact further. And then we have fail login with only username, fail login with only password, yada, yada, yada. And then we have test case 1.7, which is successful login with correct username and password. And that is the main success scenarios. That is 1, 2, 3, 4. And for that, I only have one test case. I don't try with 2 different users. Perhaps we should try with 2 different users for this. I mean, it could be that the user that we can log in with is hard-coded into the system, and users that we register into this login system or something like that we cannot log in with those. I have a couple of test cases that make sure that you are actually logged in if you reload when you have, if you reload, you're still logged in and stuff like that. To make sure that we actually get a HTTP session. And I mean, these test cases are not either seen so in the use case. These test cases are sort of derived from using the technology of the web, to using HTTP messages, to make sure that we're actually logged in. If we reload the page, I mean, that only exists on the web. If you have a console application, I mean, that would imply other test cases. So the platform and the system itself generates test cases also. Okay. I've shown you this one before also. This was the requirements pyramid. So the needs of the user is up here. And these are sort of what we try to capture when we write requirements. And needs of users is, for instance, that the need for having an authentication system is that certain people within our company, for instance, should be able to access information, and other people should not be able to access this information. That is the basic need. From these needs, we derive features such as the login system. From the login system, we derive use cases such as authenticate user, and perhaps also log out or registered user or something like that. So we can have multiple use cases for a single feature. Sometimes features share. So if this is the registration system that customers needs to be registered in order to shop in our web shop. So we have a register system. So there are interaction between the registration and login or authentication system. And we also had a specification. So these 2 parts here are symbolizing the specification. And the specification, we've seen that that could be things that it should be user-friendly and stuff like that. So from both the use cases and specification, we derive test cases. But with the use cases, we first look at the different scenarios. I mean, sort of the scenarios, as you've seen, are different paths through the test case, so different ways that we can interact with this. And if we have a loop, which we do in this one, we can have infinite amount of scenarios, because we can have many steps through this loop, and we can think the same way as we did when we assessed code coverage with these graphs. So we can have loop coverage here, for instance, over our use case graphs, so that we say that the loop containing 4a should be accessed 0 times, 1 time, and many times, or something like that. And then we're satisfied. Okay, so from these we derive test cases, and a single scenario, which, for instance, the failed login was a single scenario, right? I derived 5 different test cases for failing login. Not providing information, not providing password, not providing username, wrong username, right password, wrong password, right username, or whatever. So we can have many different test cases for each of these. Yeah. Okay. I've also shown you the traceability matrix. Since we get so many test cases, we need to some way communicate how well we are covering different use cases, really, and to be able to communicate how good we are at testing, more or less. And the way I'm going to show you this is the test traceability matrix. And we talked about this the last time. So we have the requirements up here, and then we have test cases as the y-axis. And if requirement 1 is covered, or so if test case 1.1.1 is testing requirement 1, then we have an X here. And we can see that the 1.1.1 is only testing requirement use case 1. We can also see that we have a naming strategy that is also giving us traceability. So I think for assignment 2, you should make sure that your naming strategy for your use cases and test cases use this method. And it's pretty simple. You take the use case number as a prefix for the test case number. So 1.1 means use case 1, and then the third number is the test case number. This can be done differently. Of course, you can have like UC 1.1, TC 1, or something like that, to make sure that these numbers are interpreted the right way. I would say that the complete picture of coverage over a use case is not super easy to achieve. A good way of showing coverage would be to show this graph for each test case, and perhaps also show this graph coverage, the path coverage or the loop coverage of this test case, to explain that why do we have this particular test case? Yes, it's because we need to step 2 times through the loop at some point. So I think one of the nicer assignment 2s I have seen used these graphs for each test case, more or less, so that it could be easily seen. Okay. When we generate these test cases, we cannot cover every possible way of testing the system unless the system is super simple and takes super simple input. The way of testing everything was called exhaustive testing. That was when we test all inputs in the input domain, and the input domain consisted of all possible combinations of inputs. If you have a loop that suddenly becomes impossible because we have an infinite amount of inputs. It's not practically possible in most cases and would result in a too huge number of tests. This is also repetition, but the way that we should think about this is that we should not try to generate super many test cases, because that probably won't help us anyway. So we should not strive to be exhaustive. We should strive instead to select a smart number of test cases, a subset that would reveal all errors in a program. So we need to be smart about this instead. And the way to be smart is to have some strategies, do some assumptions, and we're going to talk about that in 10 minutes. Okay, so welcome back to software testing. And we're deriving test cases from requirements and from code. And we repeated some parts of previous lectures, but I was talking about the test selection problem and exhaustive testing, which is not practically possible. But the test selection problem was to select a subset of tests, the good tests. The good test would reveal all errors in a program, but the goal of testing as an activity is not only to uncover errors, it's also to build confidence in the software. So not only do we need to find tests that are good at finding problems, we also need to find tests that sort of make sense so that developers and customers and everyone who relies in the software that we're creating is going to be happy about our product. And the image here was from a game. Perhaps it doesn't really matter so much for the overall experience of playing a game if we don't see every horse in the game. But perhaps it's embarrassing. It shows us to be not as good coders as we could have been seen as after releasing this game. But all of these sort of narrows it down. Okay, what is a good test suite? And what are the different things that we want in order to be able to both uncover errors and build confidence? So I would say coverage is one of those things. We want to see that every requirement is covered with perhaps a couple of tests, and that every scenario is covered, or at least the most important scenarios. So in order to show that we've done a good job, we make a strategy for how many tests we're going to have from each use case. And we draw these diagrams from the use case, and then we show that we follow different paths in these. We hope to find bugs if there are bugs. And I mean, this is much harder than it looks like, because most bugs are not that obvious. If they were obvious, the programmer would have found them. There are many cases where the bugs are because the programmer did some assumption and they are hidden deep in the code. And I probably told you the lecture about me chasing around a bug for 6 months. That was not really in my code anyway. But okay. We want our test suites to be automated or have the potential to be automated. And the reason for this is that testing can, or I should say this, checking or running tests can be boring. It's painful to regression tests over the same thing over and over again, especially when the test cases are many steps. So in the case that we've seen before with the login system, some of the test cases require us to first go to the web page, or perhaps we remove a certain user, and then we go to this web page and then we register a user, and then with this newly registered user we log in with that one. And perhaps we need to reload the page again or something like that. So it's many steps and many different inputs that we're going to make. To do that over and over again is boring. And in order to stop being bored and also to improve the speed of testing and the effectiveness of testing, then we want to automate things. And this is the second reason for having explicit input and explicit output, to not have tests that are vague in its input. If you have explicit input and explicit output, then you can automate these manual test cases very easily. So I think that this should be the goal of when you write your manual test cases. You do that with the goal to to sometime in the future automate these. Perhaps you record the input through different web browser plugins. Perhaps you write another application that interacts with your application. Perhaps you have behavior-driven tests where you have frameworks where you can interact with your application, stuff like that. The next thing is that the test should be easy to change when the requirements change. So in a software project, requirements are not set in stone. They change. And the reason that they change is that when we have a stakeholder that has some need, they don't fully understand the best way of fulfilling that need, and perhaps they don't understand the full need that they have. So when we give them some version of the system, and suddenly their need can be fulfilled in some way, they realize that this is not the best way. So we should be prepared to change things. And the more work we have done with our tests, the harder, I mean, if we formulate ourselves, we write long texts of how to test this and why and things like that. And then the requirements change. Perhaps that text needs to be changed also, or thrown away in the worst case. That means that we need to think about being a bit agile also. If we spend a lot of time to interact with if we automate tests, we write code that run these manual tests perhaps. If this is very complex, then perhaps it's not as easy to change the requirements anymore. If it's not easy to change the requirements, perhaps we don't want to change the requirements. If we don't want to change the requirements anymore, perhaps other people who are willing to change the requirements will get their software to go ahead and be sold instead of ours. So I mean, we need to be smart about how we implement things. And one way of being smart about it is, for instance, to reuse text that is already been written. So in this lecture, I've given you the example where I reuse the input from one test case in another test case. And yeah. Okay, preferably test suites should be quick to develop and can be used during development. So we get these really early, and then we can give these to the programmers, or we as programmers write these. We would like a minimal test suite that gives us enough confidence. And I mean, this is very vague. And we want the test suite to also, ideally we also want we just run this test suite and then the customer is happy with this. So it also contains the acceptance testing. Yeah, I mean, it's up to the customer to really to decide what is good enough, but often the customer doesn't know. So we need to help the customer with this also. Okay, in order to get that, we need to not write every test in the world. We need to make the good tests. And guiding us are assumptions. So we make some assumption of the system in order to guide our testing effort. We want these assumptions to be as informed as possible. And one such assumption could be like this. So when we're going to run our tests, let's only run the tests for the different parts that have changed. Let's not run every test. Let's run those that the code changed for. So that is an assumption to regression test only the changed parts test. It might be successful. It's a good assumption, because if we don't have flaky tests, if you don't have interpretations in our, if our tests are not easily interpreted, then for the parts of the system that did not change, the test results should be the same, right? But it's still an assumption. We don't know everything about this system. It could be that we're wrong. And there is a famous saying that assumptions is the mother of all fuck-ups, which means that we might fuck up, but I mean, okay. So what are the different assumptions that we can make? And I'm gonna go into that soon. We're gonna step back to black box testing first. And black box testing was to examine functionality from the outside without knowing anything about the internals. Perhaps we're going from the specification and looking at the specification, and we say that square root for an input of 9 should output a 3, because that's how square root works. And what is the output for a negative number? Perhaps that is also said in the specification. But we already learned that the specification is not everything. So we need for manual testing, we need an implementation in order to know how to write our test cases. But for a simple method like max, so here we have 3 inputs instead, we can derive different test cases using that. So let's assume that for every case where A is the highest number, then it is also returned. Perhaps we only need one test case where A is the highest number. And then let's assume that for B, when B is the highest number, then it's always returned. So let's only have one test case where B is the highest number. And then for C, the same thing. So for this one, perhaps we only have 3 different test cases. We could assume more things from a black box perspective. We could assume that, okay, perhaps we should have one test case where the last item is returned, C. And let's have another test case where A is returned. If we have those 2, then we assume that the system works. Perhaps that is enough. If we have 50 inputs here, if this is a list, perhaps that is the way that I do it. I don't check every possible list or stuff like that. The more I assume, the more I'm, the higher the possibility that I'm wrong. So one way of assuming things is that, or the thing that I used here was actually equivalence partitioning. I say that for every input of this kind, we will get a similar result. So equivalence partitioning is to divide the input domain into equivalent disjoint subsets. A subset means that it's a part of the input domain still. So in the picture in the right-hand corner, then both these boxes together, the set of both these is the input domain, the complete input domain. And we divide those into equivalent subsets, means that they should work in the same way for every input in this part or this subset. So the system should work for the same way. And disjoint means that no single input is in both. So we cannot, if we have the 5 here, we cannot have the 5 here. We have a -5, but we don't have the 5 here. So no single input is in both. There can be many of these equivalent partitionings, and usually we select one test case from each. That was what I did when I selected A, B, and C for the max method, right? I took one where A is the highest, one where B is the highest, one where the C is the highest. So in this case, we have a function that is called addUser. It takes an age. I don't know what it returns because it returns void. Perhaps it adds user to a database or something like that. And let's assume that valid input is age between 0 and 120. Name, I probably changed this example to make it simpler, so name is no longer used. So we only have age up here. So 0 is a valid age. You can be 0 years old. 3, 5, 120 is fine. 121 is not fine because that is too old. And -5 is not fine either, and 2 billion is not fine either. Given just equivalence partitioning, we should only take one of these from each. That could be a good assumption, and usually what we do. Okay, given more information, we can do better. So instead of black box testing, we can think, what does it mean when we also have access to the code? And that was called white box or glass box testing. Given this, or the source code, we suddenly realize that we need to cover things. So in order to cover the method here, we need a lot of different inputs. And sort of the different paths through this one gives us probably different equivalent partitionings. So in this case, I need to step into each one of these different if statements separately, perhaps, and I need different combinations in order to get this. I'll get a lot of different test cases. And sometimes, when the code does look like it can be very simple to divide into, from a black box perspective, divide into valid and invalid input, or it looks like the max method, but inside it's a lot of different code, or a lot of code. Then it's hard from a black box perspective to write tests for it. And one of those cases perhaps is this one. So here we have some internal buffer we call read. And the read method reads from some buffer. Perhaps we input into that buffer through console or through system in or something like that. But just looking at the code, what are the equivalence partitions for this code? I easily find one, and that is sort of the if statement. So the if statement sort of divides code that contains a \n is simple. If it does not contain a \n, then every string that does not contain those, we can partition those into one, right? For the other part, it's not that simple. For the other part, we have strings. We need to divide this string into substrings and stuff like that. And perhaps equivalence partitioning does not really work for us here. Perhaps we need to think of other ways of doing this. It's not impossible to create partitions for that one, but it needs more thought process. Okay. Given partitioning, we can also combine different partitions into multiple dimensional partitioning matrices. So let's think about the age thing, and let's add a salary to that one. So another dimension of input. So we have a rule that says that if you're between 18 and 65, you can get a loan at this bank that we're writing an application for if you make more than 25,000 pounds a year. So you have age in year, and then you have salary in pounds that is coming in. First, we need to identify the input domain. So age is from 0 to 120 or something like that. And then salary can be from 0 to super high, I guess. And perhaps and then we have we equivalent partitioning the age and salary into different subset, and then we combine these. So in the end, you end up with a matrix. And I'm not sure, yeah. So the matrix contains different parts where the age is on the y-axis and the amount of money is on the x-axis. So if you're zone E5, then you're eligible for a loan. Then you're old enough, but not, and young enough for a loan, and you're earning enough money. So if you're in E1, then you're too young and too poor. And if you're in E only, then you're too young, and but you're rich enough to get a loan if you had age enough. But so we probably should take at least one test case from each of these boxes in order to cover all these. Okay, so that is one part of the story. So perhaps 6 test cases. But if we had access to the source code and we realized that there are really 2 if statements here, and 2 if statements can go in 4 different combinations or something like that, perhaps we can lessen the number of test cases. Given the source code, we have more information, we can make better assumptions. Okay, this was part of the equivalence partitioning thing. You probably heard about this before. Then we have boundary value analysis. And this is based on, I'm not going to call it a fact, but the belief that programmers often make mistakes on the boundaries of these partitions. So it's quite common to use the wrong number or the wrong comparison operator. It's a common error. So for that reason, we create test cases on the boundaries of these partitions. So we still partition input domain, we identify the different boundaries. And the boundaries is the axis here, so 24,999 and 25,000 is the boundary, right? So for this case, you perhaps create one test case in E1 where you are 17 years old and too poor. You have 24,999. And then you have another test case on the other side where you're old enough, but you're still too poor. So you're 18 years old, and then you have 24,999. And then we have one test case where you're 17 years old. Yeah, that was the same test case, but then you need a test case on this side of the boundary also, where you're 25,000 in income, but 17 years old. Yeah, and you see there are different test cases on each of these boundaries that you need to make, and some of these are going to be the same as other test cases, so it's not going to be you can combine these a bit, but you create test cases exactly on the boundaries, on both sides of the boundaries. Okay, that was more or less the last part of the lecture, and sort of given all these lectures, some are more complex than this one, you should now have a pretty good idea about how to test things. However, a large part of this course is the assignments. And these assignments contain a lot of different things that you're supposed to ask about. And I'm really happy about the different questions that I get in Slack. And I want you to be active in Slack. I want you to ask the difficult questions to us. I receive excellent questions and I'm very happy for those. So continue to ask those. How am I gonna interpret this requirement for this scenario? They're very good questions, and continue to ask those. I'm gonna be a little bit less active in Slack this week just due to other things I need to do and examinations. So continue to ask questions about this. I'm going to step through the two different assignments, but I think we need to take a 10-minute break before we start with that. Okay, welcome back to software testing and this third part of this lecture. So we're gonna talk about assignment 2. To begin with, an assignment 2 is a big assignment, and it contains a lot of different things that you should think of and consider and discuss with your other group members or discuss in Slack. So I said that I welcome questions on this assignment. The difficulty of this assignment is that you're really taking full responsibility for a testing effort for something that you've not encountered before, perhaps. So you get requirements, you get source code, and you also get a specific scenario. This scenario, you have a lot of room of interpretation of this scenario, so you can make decisions based on this scenario. But the requirements are not written for this scenario, which means that there is a gap between the requirements and the scenario, and the scenario could like create new requirements that you need also to consider. This is what makes this difficult. Also, there is a gap between the implementation and the requirement. Things are buggy, things are perhaps omitted. Fault of omission was when something was not implemented, right? So there might be things in the requirements not yet implemented. And in order to do good in this, you need to understand all of these different things. You need to understand the scenario, you need to understand the requirements, and you need to understand the software. The requirement is given as a requirements document, much like the one that we looked at before. So it has a supplementary specification. It contains a couple of or 5 different supplementary requirements. And it also contains a description of actors and their needs and their responsibilities, and then some use cases. Not all use cases are, the use cases more or less look like use cases does. So it's an interaction between a system and some actor or some actors. And one need to read these and try to understand what it means, really. But also you need to run the actual system and see if you can find these things. So in this case, I think it's start the web server. And for instance, this phrase here, system ask for socket port and a shared resource container. It sounds like we're gonna get a dialog box where the system asks for something, and you should write in some input field the number that you're gonna use for socket port and the shared resource, whatever that means. It sort of sounds like you're doing it in a dialogue. But really, you're starting up the application with these as arguments. So this is the port, and this is the shared resource container. So one must understand that the developer of this system did an interpretation of the requirement and interpret that as, okay, when the system asks for this, it's really arguments to the main method, which is a bit weird, perhaps. But if you know web servers, they need a port number, and they need a shared resource container to be a web server. So it makes sense to give those things to it. It could also, another interpretation of this could be that we place these in some config file. So Apache web server, for instance, you have a config file which contain the port and the shared resource container and some sharing rules and stuff like that. So you need to learn these things about the software and about the requirements, and then you need to mix and match, and then you create these test cases for these. In the end, we can have multiple different interpretations. So I can imagine that this particular requirement can result in a test case which fails because there is no question for the port. And I can imagine another test case that succeeds because the system asks for the requirement, but in this way, right? And both of these interpretations are correct, so to speak. So there is not a single correct way of thinking of this. It's different interpretations. It's a bit weird. So not weird, it's what it is. And I mean, reality is also like that. So don't be. So how are we going to, when we read this, how are we going to judge the effort of the student? So since you're going to review other students, I've tried to write some reviewing guidelines. And I mean, first of all, we need to use English. We're going to communicate things. We try to make it easy for the reader. Therefore, we try to remove spelling and grammar errors. We try to use perhaps not the most complicated English. We format and layout this so that it can be read. We use PDF files, not Word files, not some other format, no markdown files. We use PDF, and I would say that it would be fine to give a low grade to someone who submits a Word file here. So export your Word file into a PDF so that you fulfill all of it. And I want you, when you write these, not only for review, but when you write your documents, read and make sure that everything in here is fine in your document. Use tables, links, titles of different levels so that it's easy to read. Disposition your chapters so that you can read it from top to bottom, so that you don't need to step back and forth. If you need to refer to something that is much later in the document, you can repeat some of the text. You should not repeat much of the text, you can repeat some of it. It can be a good thing, for instance, with use cases or things that have some code. TC 1.1.1 is hard to remember what that meant. So TC 1.1.1 navigate to site is a better name because it also contains a bit of information that guides the reader to the actual test case. So when needed, I mean, repeat yourself when needed, not too much repetition. And the reason for not too much repetition is that we want to be a bit lightweight. Okay, next part is completeness of this. There are different things that should be in this document. So the strategy should describe stakeholders and their testing goals, available resources, and also how the stakeholders' testing goals are going to be fulfilled by the plan. And then we have the plan. I mean, between test strategy and test plan, I mean, there is an overlap here. The last part here is about how the plan is going to work. So when we read these, and we perhaps should be a little bit forgiving if some part of the strategy leaks into the test plan, and if some part of the test plan leaks into the test strategy. I mean, it's fine to move things for readability and things like that, but more or less these three things should be there. In the test plan, it should describe what requirements that should be tested, what requirements should not be tested, perhaps some reason for them not to be tested. And how testing should be done, at what test level, what are we unit testing, what are we writing manual test cases for, what are we automating, what are the acceptance tests. So that's easy to see that these different tests belong to different test levels. And it's a plan. It should describe who should do different activities. What are the responsibilities of the different roles that are given in this document? So as resources, you are a resource really when you're a part of a group, or if you do this alone, you're a resource and the hours that you have. So the test plan should describe who within this group does the different things. If you're alone, it should say that tester number 1 does all, more or less. And there should also be a test document. So just see, yeah, the test cases document. And this should contain manual test cases. Each of the manual test cases should be traceable to a requirement. We have talked about this today, that you can create codes for how the test case has a code. Test case 1.1.1 means that it's belongs to use case 1.1, and each of the manual test case should describe input and expected output when relevant. And then you have a test report. This test report should show what has been tested, what has not been tested, and what has not been tested. If you create test cases, of course you have also run these test cases, right? But in a more expansive test report could say that we did not run a certain part, certain test suite in. So I expect for most of you, you have run all your tests, right? So it should show which tests fail or succeed. I very much like colors here. So some colors, different colors for different results perhaps. And you should also think about, is there testing the other group should have done that they didn't do? So the last part is perhaps more a content or the effort thing, because the last thing that we're going to review is also the content, right? And this is the effort of the other group. Have the other group done a good job reporting their testing of the product? So this is a sort of a measure of their ambition and test effort. Given their resources, have they done a good job? Given the resources, have they even done testing in some cases? Do we have coverage? Do we cover relevant scenarios in the use cases? And do test effort cover the relevant requirements at all? So you can have different answers to what is good depending on the group size. So I think this last part is where you should consider, okay, there are 4 of them, it's 1 of me, I did more testing than they did, perhaps they should have done more. Right, so you can relate a bit on your own testing effort. Or if you find out they have done much more than I have done, or than our group did, then, so you can think of this as a bit relative to your own effort, right? Yeah. In the end, you're going to receive reviews. These should be anonymous, no names or traces of names. And you should aim to help the other student group to become better testers and better document writers. That's the way you're going to write. And this year, we're not going to show any scores. So you're not going to receive scores from other students. You're still going to give scores on other students. But it's important to know that these scores are then reviewed by us as the teacher group, and we're going to like change these scores a bit and adjust things. But give constructive reviews. Think of these, and you should also, there is a deadline for this also, you should give feedback on these reviews that you got. So think about how good were the other person that reviewed your group's work, and I think that these feedback should be individual. So don't sit down as a group and go step through all of these. Do this individually. Yeah. Sometimes you receive reviews that are not complete reviews, that seems that they didn't even read your thing, that it contains errors and stuff like that. Then write that. Try to still be friendly. I mean, we should not, it's not a food fight thing here. It's still about helping. And it's sometimes it's the case that people are not able to concentrate for a very long time, or whatever reason that they could not do, or they ran out of time, or get interrupted and needed to submit, or whatever. Things happen. So be kind. We don't accept any fighting. And then you're going to be graded. And it's very important to know this. You're going to get 1 grade for the actual document. And then you're going to get another grade for the review part of you as a reviewer, so to speak. And the review part, you can affect that by doing more work. So the more reviews you write, the more reviews, the better grade you can get. So, for instance, for E, for the minimum level, you need to write 2 reviews that both get approved. So these reviews should be approved. They should get a grade from us. And it's not only the authors that is involved here, as it says here, it's also me and the group that when we are reviewing your reviews and reviewing your review feedback and stuff like that. Yeah, in the end, if you want the highest grade, you need 4 peer reviews, and at least 2 of those should be getting the highest level, and then the other 2 can be good or higher. Yes. So, any questions on this? And I mean, you're very welcome to ask questions during the entire process. But this is an assignment that takes time. It should take minimum of 20 hours, so 3 days of full-time work, or a complete week of full-time work. And I'm guessing you have other courses to do also, so I mean, plan this so you don't start the day before. Okay, that was the second assignment. And then you also have a third assignment. Let's see. Should we have a Git repository for this assignment? For assignment 2, you don't need a Git repository. You're welcome to have one private repository for assignment 2. So let's take a look at the third assignment. So the third assignment is a video presentation. It's individual assignment. And you should look at or read a peer-reviewed scientific article. So with paper, I mean scientific article here. From a critical standpoint, you should discuss the validity, that how it works or how it looks like. And you should read and understand scientific literature. First, you need a peer-reviewed scientific article and subject of interest in the field of testing. So try to find something that sounds fun to you. And I want it to be quite recent. Doesn't say any specific year here or something like that. What is recent is relative, but don't take something from the 1970s or 1960s or something like that. Take something that has happened the last 10 years. If you find a super interesting research paper that is a bit older than 10 years, fine, if you really, really want it, but aim to get a new one. It should be in the field of testing and not something else. I mean, by now you should have a quite clear view of what testing is. If you don't have that, look at the first lecture and then select one of these. It should be peer-reviewed. And peer-reviewed means that scientific articles, they go through a process, just like your assignment 2. When we're going to publish a scientific article, I need to send that to some reviewers. It's often an anonymous process where these reviewers don't know me and I don't know who they are. And they read the things that I as a scientist write, and they do very critical reviews of these. So, and this should increase the value of my work, because everyone knows that if I get it published, it's good stuff, because other people have other scientists, experts in the field have read it and decided that this is good enough for publication. So it's a way of making sure that articles are of good quality. Of course, just like assignment 2, sometimes some reviewers are not doing a good job. Perhaps they don't understand and they still do a review of it. Perhaps they don't spend enough time on it. So there are actually a couple of, I think it's a very famous system. I don't know the name of it, but there were some computer scientists that wrote a system which wrote scientific articles. Machine learning. And they wrote scientific articles or document that looked like scientific articles. So they have all the relevant part. The text was readable, but it didn't make sense. And then they sent in these papers to a number of journals, I think. And some of these got published. So, I mean, it shows that not every journal is really good at reviewing. Perhaps not every journal does review. And then there are some journals and some conferences that are much harder on this than others to show that we're the good stuff. If you get your stuff published at our journal, then we really guarantee this is the best thing, right? So that is sort of why we want. And I want you to select an article that has been peer-reviewed. The way to do that is to use some database, and I'm giving you 2 different links. And in order to access this database, you need to log in through LNU's, Linnaeus University's library functions. So even if you're online, you can, using your student ID. I'm not super sure how this works because I always use it from the university network. But you can log in from home using your student account and then get access to this. Perhaps we can guide you a little bit in Slack, so if someone has problem, then look at this. So I'm giving you 2 different databases to select from: ACM, Digital Library, and IEEE. So I'm just writing unit testing. And ACM can be super slow. And actually I'm logged in through my cell phone because network is not working. Okay. Getting results. Oh. Okay, this sounds fun. Contract-driven development equals test-driven development. Writing test cases. So I'm just clicking on that. And we can see, okay, how was this published? It was published in the proceedings of the 6th joint meeting of the European Software Engineering Conference and the ACM SIGSOFT Symposium. This was a bit older than I asked for, 2007. So perhaps if this is not your super main interest, perhaps select a newer one. Site maintenance. This does not look that good. But I would search for this conference, and I have not done this before, so everything can show up. So this is the website of the conference, right? And here we would like to get some information about if this is peer-reviewed or not. Most cases, and the reason that I give you these IEEE and ACM is that in most cases these are peer-reviewed. If it's published on a conference or in a journal, then it's most cases peer-reviewed. Sometimes it can be really hard to know. So I think if you go into one of these two things, then make some effort to look if it's peer-reviewed or not. If you don't find it and it looks like a scientific paper, then it's probably okay. A scientific paper usually look something like this. If it's more than 4 pages, then I would say it's fine. If it's like 2 pages, then it's usually not a complete scientific paper, then it's a poster or something small, like they only publish an idea and not any results or something like that. It usually has some kind of introduction that is a short form of the entire paper. This is the abstract, and then it explains the problem, and then it motivates why their research is needed. And then it starts with their content. And in this case, I'm going to see, they're just talking about different stuff. And in this case, they perhaps really didn't have any way of evaluating what they did. But I have given you a couple of questions here. And if you can answer these questions, or most of these questions, then you're probably selected a good paper. So when you read the paper, try to find out what kind of problem, or what are they do, why are they doing what they do? If they have something to solve and they've sort of tried to solve that, yeah, that's a good thing. If they present a problem and they try to fix that. And then they should probably have some kind of method, what they did, not what other people did, what they did. And then, given that, they should get some kind of result, some kind of data collection, or some interviews made, or there are different ways of doing scientific stuff, right? But so the result can look differently depending on this. It can be running some experiment on people or on systems, or calculating different metrics, or doing a lot of statistics or stuff like that. Then I want you to see if they are critical to their own work. So, and that is called validity. And I think I've given you a link here. So please read up on validity on this page. So this is Wikipedia. And validity, there are a lot of different things. But in general, validity means that can we, given what they've done and the results that they give, does that give us any answers to the question that they try to answer, really? Or is it just they're presenting their idea? So if let's say I've written the CS quiz system. It's part of my research. And I say that every student liked the CS quiz assignments. They were super awesome. Then I must motivate that by collecting some kind of information, right? Like asking you if you find it awesome or not, right? If I don't do that, then it's just my illusion, delusion, right? But if I ask you and like 90% says, oh, it's super awesome, then we suddenly get some kind of result. But there is a validity problem here. If I ask you the question, especially before I grade you, then it might be a bias problem because you have a dependency to me. So I'm not only your researcher, but I'm in a power position and stuff like that. So if I've done that, I can still ask you, and I probably have asked you if you found those assignments okay somewhere. But the result, I must discuss this myself. So I should be aware that this problem can exist. I should have done what I can do to rule out that problem in order to find out the truth, but because sort of the truth is more complex. So that is validity problem and bias and stuff like that. And then try to see if their research solved the problem or answered the question. And then they should also present something like, okay, what are they going to do next? I think, didn't this one future work? Sounds like things they're going to do next. And then in the end, okay, now you've read this. What do you think of this? Do you think, given what they say, all the things above is more or less what they say, do you believe them? Do you believe that the paper on CS quiz, that it was so awesome, is actually true? Or do you find some holes in their arguments that you can pinpoint or find? Do you think that they give enough evidence to say what they try to say? It's very, very common that scientists are trying to say more than they have evidence for. So, and I mean, so this is, yeah. So hopefully you learned something about cutting edge testing technology here. And hopefully you also learn something about being critical and how testing is evolved now. Because most of the things we're talking about in this course is like 60 years old or something like that. I mean, equivalence testing today is probably before I was born. So hopefully you find something like that. And these thoughts and these questions is really good to have in mind also when you do later courses where you need to read scientific papers. So that is why I give you them. So you're going to read those and you're going to answer these questions, and then you present those answers, or most of those, in a YouTube video. I've probably not fixed this link yet. And then in January, I think you're going to look at 2 other students' videos, and you're going to ask them questions on their video content that shows that you've watched it. So watch the entire thing, write a question, and it's quite fine if you continue to interact, because you're going to get a couple of questions on your videos. Answer those if you can. Or if you can't, then just say thanks for the question. I don't know. But we're only really going to look that you watch 2 other students' videos and ask the relevant question. Okay. Hopefully this will be a fun part of the course also. Thank you very much. And so this week is going to be examinations A1 part 2. Next week, I think there is a planned lecture, right, in schedule, or do we have that? If we have one, I'm probably gonna have a questions and answer session. There is one, right? So I'm gonna have questions and answers and see if I find things that we've sort of missed during the lectures. Okay, thank you very much.